One of the things we're always interested in math is how to solve, which is to get the solutions to an equation, which usually corresponds to x-intercepts. According to the fundamental theorem of algebra, a polynomial can be factored into the product of linear factors, things like x minus 2 or 2x plus 3, and irreducible quadratics. Irreducible quadratics means that they do not have any real solutions. The corollary to the fundamental theorem of algebra is that a polynomial with n degree will have n complex roots. So in this first problem, if I have a degree of 3, it means I should have 3 roots in my answer. So in this first problem, what these are going to do for this first day is they're going to give you one of the factors or roots. So our first step is going to be to divide our box. If you want to try that on your own, just press pause and play it when you're ready to see. So we have x cubed, this is x squared, negative 3x squared, negative x squared, minus x, 3x, 9x, 9, and I made a mistake somewhere. It would help if I wrote down the problem correctly. So it'd be minus 27, sorry. Okay, so I did do it fine. Okay, now I have a quadratic, which is great because I can always do the quadratic formula. I like to check and see if I can factor it first. So is there something that multiplies to 9 and adds to negative 1? No. So that means I do need to do my quadratic formula. So the first root I've used is 3 because x minus 3 equals 0. If I solve that, I would get 3. So you always need to write the one from your factor. And then I would do my quadratic formula. So x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So I would get 1 plus or minus the square root of 1 minus 36 over 2. So 1 plus or minus the square root of negative 35 over 2. And the only way I'm going to be able to simplify that is to 1 plus or minus. That is a bad plus or minus. 1 plus or minus the square root of 35i over 2. So once we get down to a quadratic, we're happy because I can always do the quadratic formula. Alright, this next one gives me a root, so that means I need to change it to a factor in order to do my division. So I'm going to divide this polynomial by x minus 1. So that would give me x cubed, x squared, negative x squared. I need another negative x squared, so this is negative x, positive x, minus 2x. So minus 2, positive 2, and we have our quadratic, which is great, and I always check with factoring. So is there something that multiplies to negative 2 and adds to negative 1? Yes, my x works. Multiplies to negative 2, adds to negative 1 is going to be negative 2 and positive 1, so that means that my quadratic factors to x minus 2, x plus 1. And if I set each of those factors equal to 0, that means I get my solutions are positive 2, negative 1, and then I bring down my 1 that I started with. Technically, you could put those in number line order. I'm cool if you just write them down. Okay, this next one is another one where they give us a root again. So if I have 4 as a root, that means x minus 4 would be my factor. So I'm going to divide by x minus 4. So this would be x cubed, x squared would give me a negative 4x squared, so I need a 5x squared, so this is 5x. This is negative 20x, so I need a 4x. For negative 16, so that one worked. I like to check by factoring. If you want to use quadratic formula every single time, have fun. So is there something that multiplies to 4 and adds to 5? Yes. 4 and 1. So that means my quadratic factors to x plus 4, x plus 1. So that means that my roots, or my solutions, are negative 4, negative 1, and then the positive 4 that they gave me to start off my problem. Same thing, this one gave me the factor, so I'm going to divide by x minus 2. This one's going to be longer because I'm starting with something to the 5th power. So I have 16x to the 5th, so this would be 16x to the 4th, negative 32x to the 4th. Oh, but this is nice. I already have that in my problem, so I go on to my negative 81x. So then this is negative 81, and I really hope negative 81 times negative 2 is 162. And it is. And I am very happy with this one. Why am I happy with this problem? It's a difference of squares. So that means I can factor this to 8x, what am I saying? Sorry, 4x squared minus 9 times 4x squared plus 9. Now what I need to do is set each of these factors equal to 0. So 4x squared minus 9 equals 0. I would add 9, divide by 4. Please leave it as a fraction. If I do plus or minus the square root, I would get x equals plus or minus 3 over 2. Now it's going to be really similar when I do the next part. So 4x squared plus 9 equals 0. So 4x squared equals negative 9. If you can do any of this in your head, that's fine. X squared equals negative 9 over 4. So when I do the square root of both sides, I would get x equals plus or minus 3 over 2i. So this gives me all 5 of my roots. I have my original root of 2. I have positive and negative 3 halves. And I have positive and negative 3 halves I. Now, there are a lot of different ways once we start these problems that we could do it. So I could have done quadratic formula on my 2 quadratics that I ended up with. But if I don't have a b term, I don't have something with an x, why do that? You can just use the square root method. I also could have factored this first one as a difference of squares again, but I still would have needed to do the square root method with the second binomial. This next one we introduce some new terminology. So solution, that's the same thing as saying a root. So if I have a solution of negative 6, it means that I have a factor of x plus 6. So 2x cubed, 2x squared, 12x squared, 5x squared, 5x, 30x, minus 7x, minus 7, minus 42. So you could do quadratic formula. I'm going to check factoring. Is there something that multiplies to 2 times negative 7, negative 14, and adds to 5? Let's see. Negative 14 adds to 5. Yes, 7 and negative 2. But I need to do the x box on this one since my leading coefficient wasn't 1. So I'm going to do first term, first box, then 7x minus 2x, and then my minus 7. And when I factor that out, I get x, negative 1, 2x, and 7. Check with your multiplication. It looks good to me. So if I set 2x plus 7 equal to 0 and x minus 1 equal to 0, I'm going to get my other two solutions. They already gave me the first one is negative 6. Then I'll have negative 7 over 2 and positive 1. Okay, next one. They give me the factor this time, so x plus 1. We have x cubed, so that gives me x squared, but I don't have an x squared, so I need to subtract. So that'd be minus x, I need another 2, so minus 2, negative 2, and then let's check by factoring. Is there something that multiplies to negative 2 and adds to negative 1? Yes, negative 2, positive 1. So this factors to x minus 2, x plus 1. So this would give me 2. And then notice, I'm going to end up with negative 1 twice. So we call this a multiplicity. So negative 1 multiplicity, because it happens multiple times. Negative 1 with a multiplicity 2. And later, I just abbreviate it as 2 negative 1 mult 2. So if you want to abbreviate that, that is fine. So let's just scan through and see how we end up with the right number of zeros. So this is cubic, so I should have 3. And I have 2, and then I have negative 1 twice, so that gives me my 3 times, my 3 zeros. The previous problem was cubic, and I had 1, 2, 3 solutions. The one before that was supposed to have 5, and I have 1. I have positive 3 halves, negative 3 halves. Positive 3 halves I, negative 3 halves I, so that gives me 5. The one before that was cubic, and I had 1, 2, 3 roots. One before that was cubic, and I have 1, 2, 3 roots. And the first one we did has 1 root, and then you would have 1 plus square root of 35i over 2, and 1 minus square root of 35i over 2. So those are 2 roots. That gives me a total of 3. So that's what the corollary is saying, that if you have a cubic, you're going to have 3 complex roots. If you have a quartic, it'll be 4, so on and so forth. So if you need to go back through, check how we did those, and think through the process on your own, and be ready with any questions you have.